Hello and welcome back to my series on rocks and minerals. In my previous episode I gave you a brief introduction about what this series was going to be about. Now I'm going to move on to the very basics of mineralogy, and that is a definition of a mineral. And then I'm going to add what a definition of a rock is. So there are 5 properties that a substance must have in order to be classified as a mineral. It must be naturally occurring, inorganic, solid, with a set chemical composition and a regular atomic structure. Now all 5 of these particular points I can demonstrate as examples in samples, but it's actually really important to understand that these 5 properties that we have here define a mineral. What defines a rock is 2 or more minerals in the same sample. So rocks are simply made up of minerals. There are more than 2 minerals seen in it, then it's a rock. So because rocks are made up of minerals, it's really important that we actually start with understanding minerals. So let's talk about what is a mineral and what isn't again. Okay, so we're back again. Excellent. The first thing that I mentioned in our list of criteria for minerals is that it needs to be naturally occurring. And this is particularly important because rocks are all naturally occurring. We don't tend to make rocks, although there are some forms of silicate rocks they use for bench tops and whatnot. But in particular, one of these is not a naturally occurring mineral. One of these things is not like the other. Which one is different? Do you know?
Am I pausing it?
No.
Okay.
So let's go through all the criteria that I said before. First of all, it needs to be a naturally occurring, inorganic, solid. So, first of all, naturally occurring. Of all of these that are there, it's probably the prettiest one which is not naturally occurring, and it's this one, and it's a copper sulfate. It's quite a pretty mineral, and if you ever see one of these really big bright blue clusters of minerals with very sharp angles, they've been artificially made. It takes probably several weeks or a few months to make one this size, but they are actually artificial. The copper sulfate is not something you actually want to have around the home, particularly if you've got small children. It is actually quite toxic. It is actually used for a range of agricultural purposes, and it is in some other chemicals that is used in industry, but it's not something that you really want to handle far too much. The edges are exceptionally sharp. It's pretty, I will grant you that. It's very pretty and quite attractive, but it is not naturally occurring. Second criteria. Crew, what was the second criteria? Second criteria.
Don't ask me, I'm just filming this.
So, naturally occurring, inorganic. Here we go. So all of these minerals, they're inorganic, but we have a fossil here. So let's see if we can bring this up closer to the camera. You can see how, do you like my pointy thing? This is for when the crew don't do the right job. So this is actually a sponge. This is actually a sea sponge, a fossil of a sea sponge. So this is not a mineral. That's why fossils are categorised separately to minerals, and so that basically eliminates that one from the group of minerals. And the third criteria, solid. Well, I think we can agree these are solid. They're not particularly liquids, so that meets that criteria. So with the regular atomic structure and the set chemical composition, that is something you're just going to have to take our word for it at this point in time. That is something for mass spectrometers and chemists to work out way beyond anything that we want to go to in this one. But anyway, I want to show you through here the most common rock-forming minerals. And the 3 most common rock-forming minerals are quartz, feldspars and micas. And I've got a number of samples here to show you. This is one of my prettiest samples. My crew have asked me to tell you that this is not Superman's
Fortress of Solitude.
Fortress of Solitude. It's quite beautiful looking, it really truly is. This is dark quartz here, Just trying to line it up with the camera. Here, in here. In rocks, quartz tends to be a dull grey colour. It doesn't tend to be one of the bright colours. We think of quartz as being more colourful, like the agates that we see, and amethyst and all the purple quartz and things like that. But really, within rocks, it'll tend to be the one without colour. So pretty much this one here is actually all quartz. So let's see if we can actually get some kind of focus. Have we got focus there? Focus. So you can see that it's shiny, it's quite reflective, it's quite pretty sometimes. And it can come in a massive form, massive meaning without shape, and it can come in beautiful crystalline forms. The quartz tends to have a 6-sided column with a point at the top. That's its natural shape, but when it comes as the massive or without shape or form, it will just be these dull colourish crystals within a rock. So then we move on to the micas. Micas come in a variety of colours. I've got some black ones here, and I've got some opaque coloured ones here. Back here, I've got a green one, which is one called Fruchtite, which is a different mica altogether. And it too is really, these are quite small crystals that you can see shining all through here. And these are a very, very prominent member of a rock-forming mineral. You'll almost see micas in just about every single igneous and metamorphic rock that you will come across, with the exception of one or two, and we can talk about that later. This is biotite. Biotite's found in granite. And you can see that micas, you can see what I'm doing here with this little pokey thing that my crew don't want me to poke them with. That's because mica has what's called perfect cleavage on one plane. And let's see if we can peel this off here in very, very fine sheets. I don't mind particularly taking this piece off, but you can slowly prise them away from each other. And this is to do with its set not only chemical composition, but its regular atomic structure. Its atomic structure means that it forms in layers. The atomic structure is forming, has very strong bonds in one direction, but in one direction only. It has them sideways and lengthways, but it doesn't have them on the top and the bottom of the crystal, which means that it doesn't adhere very well at all to its layers that have grown beneath it or above it. And as a result, we're able to do this. How beautiful is that? Eh? Now, muscovite is actually a Russian word, because the Russians used to use it to put it on their windows, little round windows in their submarines. Just a little piece of trivia there, but there you go. And the other mineral that comes in the rock-forming minerals are feldspars. So this is an example of a feldspar. So this one is an orthoclase. It has, you can see that it has its regular atomic structure, again, means that it forms in these blocky shapes and will always form these blocky shapes. Similarly, with this type of feldspar here, which are these really large crystals with very strong flat faces. I'll show you that in a different aspect. You can see that its faces are actually very strong, and that is a reflection of its regular atomic structure. Its regular atomic structure is causing it to form that way. Now, not only that, when you break the crystal apart, when you fracture it, it's actually going to fracture along these same planes. In the same way that mica broke away in one plane, feldspars will break away in two planes, in the top and the sides. And the different feldspars will have different angles, and that will determine what type of feldspar it is, will tell you what type of feldspar it is, but in this case, they're pretty well much 90-degree angles between there and there. So if we go then to having a look at a rock, so we've just talked about the three main rock-forming minerals of quartz, feldspars and micas. Great. So when we have a look at this rock here, we're looking at this. Can we get a close-up, crew? Can we get a close-up here, please? we're going to be having a look at this here. I'm going to trust him. Okay, so what we've got, I'm going to point to some little pieces here. These little pink reflective, there's a lot of pink in this one, as you can tell, with little bits of flecks of black and little bit of flecks of basically dull rubbish, which is quartz. So these little pink faces through here, you can tell that they are actually feldspars. The camera is not showing it as in much detail as you would be able to see if you actually had a little micro lens with you. But if you had a little micro lens with you, you would be able to see the same cleavage directions and the same crystal form shapes in tiny little spots as we did on this rather big one here. So this is just a really large crystal of this that's in here. But the reason why it didn't form that size is because it was growing under enormous amounts of pressure whilst it was cooling. This comes from a magma melt, and as it was cooling, it didn't actually have enough of an opportunity to grow into really large crystals. Now these little black spots that you can see through here, these are micas, but they're too small for you to really flake off as individual pieces unless you had something really, really quite sharp. However, in this sample here, again, this actually has some much larger feldspar pieces in it. You can see by those fracture planes right through here. Quite lovely. This one actually does have quite significant size pieces of mica, and it's a muscovite mica because it's not the black one. And that's what all these greyish bits are along here and around here and here. But the quartz, there's actually not a great deal of quartz in this as a percentage of a rock, but that's pretty well much what this grey, dull grey, amorphous stuff is, for want of a better word. And there's a really nice piece of mica right there. Right there, that's a really good piece of little black mica in there. Really sorry that you're not be able to see this the way that I'm able to see it, but it's the best that I can do for the moment, and I think it gives you, a pretty good idea of what I'm talking about. So that's 3 basic groups of rock forming minerals. So we've got quartz, we have feldspars, and we have micas. So together, these 3 minerals, quartz, feldspars, and micas, actually make up one of the largest percentages of all the rocks. Not doing a very good job here lining them up, are we, crew? That's all right. That's all right. I'm getting them in focus here. All right. So this piece here is quartz, and our feldspars and our micas. So in the mica range, muscovite and biotite are the 2 different main types. That green one that I showed you is quite a rare one. You don't normally find that as a rock forming mineral. But the black one's biotite, the whiter one is called muscovite, and that's found in larger grained igneous rocks like pegmatites and such. But this is what we'll be working with mostly when we talk about igneous and metamorphic rocks, and I hope to be able to get you really excited and interested. Oh, here's another really good piece. Another really good piece with some muscovite and biotite in it. So they're not really clear. Oh, that's a good one there. All these little pieces in through here. And this is actually a schist. Just FYI, this is the schist. And we've got a piece of tourmaline in here. Have a look at that. It's beautiful, isn't it? It's quite much larger grained than all the other crystals around it in terms of its size. So we generally would call that a tourmaline schist. And that's what actually has been in here. So this is a little bit in here. Someone's pulled out a large tourmaline crystal. So usually when we're talking about things like garnets and tourmalines, they've grown in schists just like this. And they make for beautiful specimens, and they can grow to enormous sizes. And this one's also got some feldspar. Check that out there. Yeah. Are you asleep yet? The crew is, but I love it. Excellent. All right. So the next episode, I'm going to go on to and show you a different range of rocks and minerals. And we're going to start off with different groups of minerals and how they're classified and why they're classified that way. And hopefully I'll also be able to load up some kind of PDF that actually I'm kind of working from here. And hopefully that will give you some paperwork and documentation that kind of goes with all of this and helps you understand it a little bit better. See you next time. So that was my explanation about what formed a mineral and what doesn't form a mineral. It seems really quite obvious once it's actually been pointed out to you, but it is actually quite fundamental in the understanding of geology. So anyway, thank you for joining me in this series, and I'll see you in the next episode. Bye.